Hello friends. I welcome you all to my channel. In this channel, I make videos on mathematics from class 6 to 10 as well as 11 and 12. This video is part of the playlist in NCERT Maths 9, where I upload videos on mathematics of class 9 following the NCERT textbook. So in this video, I will provide the solution to assignment number 1 of lecture 1, and also as a bonus I will solve some extra problems so that you get a clear idea of what I have taught in lecture number 1. And before I get started, I will highly request and I will highly appreciate if you are following my videos, and if you are having beneficial, if you are benefited from my videos, if you are learning something, then please support me by subscribing to my channel, like my videos and share them with your friends. And also do not forget to press the bell icon so that you will be notified by my future videos, as I will be uploading videos on mathematics of class 9 of NCERT textbook sequentially, chapter wise, thoroughly, with concept explanation, example problems, and solving the exercise problems given in the NCERT textbook. So please stay tuned. Now let's get started with this video. Okay, so this is the assignment number 1 of lecture number 1 that I provided in the previous video. So let's answer the problems. The first two problems, we have to select the correct choice. The first one says that every rational number is, choice A is a natural number, choice B is an integer, choice C is a real number, choice D is a whole number. Now, if you have seen my lecture 1 video, uh, you should be able to tell that a rational every rational number is definitely not a natural number, because as an example, if you take half is a rational number, but it is not an integer. Similarly, it is not a natural number. Similarly, every rational number is also not an integer, and also every rational number is also not a whole number because whole number and natural numbers are lie on the positive side of the number line, on the positive side of the origin on the number line. But rational numbers also include negative numbers, like uh, negative of natural numbers and also negative numbers like in the form p by q, like minus half, minus 4 by 5, minus 100 by 200. So it also includes negative numbers. So the only choice, even though is the correct answer is choice C, uh, the answer is choice C, even though we have not learned what is a real number, and we will soon study what is a real number as we proceed with the chapter, with the following section of the chapter, number systems. So since A, B, and D are incorrect choices, so we are left with the only choice of C. So C is the correct answer, correct choice. Now 2. It says between two rational numbers, choice A is there is no rational number. It is wrong, because we have already learned in lecture 1 that between two rational numbers R and S there is always a rational number which is r plus s by 2 that lie between r and s. So choice A is definitely wrong. Choice B, it says there is exactly one rational number. This is also false because uh, definitely there is a rational number between two rational numbers. Let's say R and S. If we consider the two rational numbers R and S, we will have another rational number R plus S by 2. So we have for two rational numbers R and S, we always have R plus S by 2, a rational number lying between R and S, where it is given that R is less than S. So we have one rational number between R and S, but we can always have a rational number between R and R plus S by 2, or between R plus S by 2 and S. So we will always have this result. So this is a rational number between R and S. This is also a rational number between R and S. Similarly we can say that there is another rational number between R plus S by 2 and S, which is R plus S by 2 plus S by 2, like this. So there are infinite number of rational numbers between two given rational numbers. So B is false, is not right, and so the correct answer is choice C, which says there are infinitely many rational numbers between two rational numbers. Okay, the problem 3 uh, asks to state whether the following statements are true or false. Now, it says the first statement says root 2 by 3 is a rational number. It is false because root 2 is not an integer. We have not studied root 2 yet. Root 2 is actually an irrational number which we will study soon in the next subsequent sections of the chapter, number systems. So root 2 is not an integer. So any rational number has to be in the form p by q, where p and q are integers and q is not equals to 0. So since root 2 here, p, which is root 2, is not an integer, this is not in the form of p by q as per the definition of a rational number. So root 2 by 3 is not a rational number. 2. Number of rational numbers between 15 and 18 is finite. By finite, it means that a fixed number of a fixed number of rational numbers means it is not unlimited number of rational numbers. A fixed number, maybe 10, 5, 20, 100, like that. And it is false. Why? It is false because we have already because there is infinitely there is infinite number of rational numbers between two given rational numbers. Uh, Now 15 by 18 are obviously rational numbers because we can represent 15 as 15 by 1, so it is in the form of p by q. Now also we can say represent 18 as 18 by 1, which is also in the form of p and q, p by q. So 15 and 18 are rational numbers, and we know that between any two rational numbers there are infinite number of rational numbers. So 2 is false. Now 3, there are infinitely many integers between any two integers. This is false. We know that between any two integers there is no other integer. If you remember from the number line, if you remember from the number line, uh, this is origin O 0. We always have these uh, between there are infinitely many integers between any two integers. This is false. Not, sorry, I said wrong. I just said that there are no integers between any two integers. No, that is incorrect. There are uh, there. It is not that there are infinitely many integers between any two integers. It There are finite number of integers between any two integers. So let's say these two are integers 1 and 2. AB represent integers 1 and 2, and over here let's say C, this is -1, this is -2. If you take any two integers, between them there has to be a finite number of integers. It is not that there are infinite number of integers between any two integers. Now you might think that what if I'd consider the two given integers far apart, one to the extreme left, far to the left of origin O, and one another integer to the far right of origin O. Far right, it is much beyond the origin O to the right hand side. The two integers are at extreme. Then you might think that there are infinite number of integers in between them, but those far extreme integers are not defined. We have not studied that concept yet. uh, you will when we will you will be in class 11 or 12. So uh, based on your knowledge, whatever we have learned so far, this statement is false. There are finite number of integers between any two integers, and if those two integers are if those two integers are subsequent integers like 1 and 2, or maybe -2 and 1, or 0 and 1, or so, then between them there is no other integer. I hope it is clear. Now number 4, says to find three rational numbers between 5 by 7 and 6 by 7. Now we have already studied in lecture 1 that there are two methods of finding rational numbers between two given rational number, method 1 and method 2. I suggested that if you are asked to find few number of rational numbers like 1, 2 or 3 rational numbers, then you might use method 1 to find them. What is method 1? Method 1 says that between two rational numbers R and S, there is another rational number R plus S by 2. Using this result, applying this result multiple times, we can find multiple rational numbers. But if the if we are asked to find higher number of rational numbers like 6, 7 or 8 or 9 or 10 rational numbers between two given rational numbers, then it is more appropriate to use the method 2. So let me, since over here in question number 4 we are asked to find 3 rational numbers, it will not take that much time if we use method 1 also. So I will solve this problem using both the method. So method 1, by using method 1, so the given rational numbers are 5 by 7 and S is 6 by 7. Now we know that using the result that uh, R plus S by 2 is a rational number that lie between R and S. Using this result, we can find 3 rational numbers between R and S. So the first one will be, we have 5 by 7 will be less than 5 by 7 plus 6 by 7 by 2. So we will have this. So in the middle, we have found a new rational number that lies between R and S. So this is, if you simplify the term in the middle, uh, uh, you get 5 by 7. This in the middle, the value will be 5 by 7 plus 6 by 7 is 11 by 7, and then we have this 2 in the denominator, which becomes 11 by 14. So 11 by 14, we have found first rational number that lies between R and S. Now we can find another rational number between 5 by 7 and 11 by 4. So we will have 5 by 7 less than 5. We are finding a rational number between 5 by 7 and 11 by 4. That will be this. So using this result, so this becomes, if we simplify the middle term, the new rational number, it becomes 5 by 7 less than, this becomes 16 by, this becomes 10, uh, this becomes 10, 21 by 14, and then this 2, 21 by 28. So we have found another rational number which lies between R and S. Now this was step 1, this was step 2, and to find the third rational number, we will find a rational number between 11 by 14 and 6 by 7. So we have 11 by 14 is less than 11 by 14 plus 6 by 7 by 2 is less than 6 by 7, and this becomes 11 by 14. If you simplify this term, it is 11 by 14 plus 6 by 7, this becomes to 12, this becomes 23 by 14 and 23 by 28. So we have found the third rational number. So the answer will be, answer is 5 by 7 less than, we have mm, 21 by 28 is 5 by yeah, so 11 by 14 less than 23 by 28, 6 by 7. So the given rational numbers were 5 by 7 and 6 by 7, and we have found in the middle these three rational numbers, which are 21 by 28, 11 by 14, and 23 by 28. Okay. Hope you have understood this. Now, let's try to find three rational numbers using the method 2. Method 2. So we have R as 5 by 7. We have S as 6 by 7. If you recall from the lecture 1, uh, for method 2, we first need to uh, transform the given two rational numbers into an equivalent rational number where both R and S will have the same denominator. So since that step is not required, since the given two rational numbers already have the same denominator 7. So the final transformation was then to uh, R double dash to multiply, to transform this 5 by 7 and 6 by 7 to another equivalent rational numbers by multiplying 4. Why 4? Because we have been asked to find three rational numbers. So 3 plus 1, 4. We have to multiply 4 with both the numerator and denominator of both the rational numbers and get two equivalent rational numbers like this. So this becomes 20 by 28, and this is 24 by 28. The final step was to actually find the rational numbers that lie between R and S. What we do is we keep on adding 1 with the numerator of the R double dash rational number like this. 21 plus 1 by 28, 20, 20 plus 1 by 28, 20 plus 2 by 28, 20 plus 3 by 28. So since we have been asked to find three rational numbers, we stopped at 3. So 20 plus 1 by 28, 20 plus 1, 20 plus 2 by 28, and 20 plus 3 by 28. And this, so this rational number becomes 21 by 28, 22 by 28, 23 by 28. So we will have 5 by 7 less than this, less than this, less than this, less than 6 by 7. So the rational numbers, three rational numbers that we have found are 21 by 28, 22 by 28, 23 by 28. So this was method 2. Now let's I would like to solve another problem as bonus problem to understand, to make you understand the method 2, because the more problems you solve, the more the concept gets more clearer to you. So you have to solve a lot of problems to understand the concept, how the formulas, how they actually work. For that, you have to solve a lot of problems. So let's say uh, you have been asked find 10 rational numbers between, let's say, minus 2 by 11 and 3 by 4. Obviously, uh, we have, so we are given R as minus 2 by 10 and S as 3 by 4. Obviously, R is less than S. R is negative rational number, and S is a positive rational number. We have to now find 10 rational numbers. Now, we cannot use method 1 to find 10 rational numbers. It will take a lot of time. It will take 10 steps. So, we will not use method 1. For this, we will use method 2. Let's see how method 2 is applied to find 10 rational numbers between R and S. The first step was to transform R and S into their equivalent rational numbers so that both R and S have the same denominator. This will be 11. Now, to have the same denominator, we said that we explained in lecture 1 that we first need to find the LCM of 11 and 4. So, LCM of 11 and 4 is, 44, right? So, we have to have 44 in as denominator in both the rational numbers, transform the rational numbers R and S. Now, so R dash, which is R dash, which that we are transforming R to an equivalent rational number R dash, where the denominator should have 44. So for that, what do we do? To have 44, we have to multiply 11 by 4, and we multiply the numerator also with 4. So it becomes 2 into 4, 11 into 4. Similarly, for S, to have 44 as denominator, we have to multiply 4 with 11. So we multiply the numerator also with 11. We get 4 into 11. So this becomes minus 8 by 44, and this becomes 33 by 44. This is, we have found R and H dash, R dash and H dash. Now to find R double dash and H double dash, what we need to do, we just multiply 10 plus 1, 11 to both the numerator and the denominator of R dash and H dash. So R double dash will be 8 into 11, because we have to find 10 rational numbers. We will multiply with 11, both denominator and the numerator and the denominator. This becomes 33 into 11, 44 into 11. Now, this becomes minus 88 by, what is 44 into 11? It is 484. 484. And this is 33 by 484. Now, as final step, to find the 10 rational numbers, what we do is we start with R double dash and keep on adding 1, 2, 3, 4 like this to the numerator. So minus 88 plus 1 divided by 484, then minus 88 plus 2 484 minus 88 plus 3 484 minus 88 plus 4 484, and like this there are so many numbers hard to accommodate in a single line. Okay, so similarly, uh, minus 88 plus 5 by 484 minus 88 plus 6 by 484. We will keep on adding and we will stop at plus 10 because we have to find 10 rational numbers. So minus 88 plus 7, 484 minus 88 plus 8, 484 minus 88 plus 9, 484, and finally minus 88 plus 10 by 484. Okay, so these are the 10 rational numbers that will lie between the given R and S, that is minus 2 by 11 and 3 by 4. If you calculate all these numbers, it will be, so we will have minus 2 by 11. These numbers will be minus 87 by 484 minus 86 by 484. Let's say we give some comma so that these are the separate rational numbers that we have found. The next will be minus 86 by 484 minus 85 by 484 minus 84 by 484 minus 83 by 484 minus 82 by 484 minus 81 by 484 minus 80 by 484 minus 79 by 484, and finally minus 78 by 484. So these are the 10 rational numbers that will lie between these two given two rational numbers minus 2 by 11 and 3 by 4. I hope you are getting the idea how to find by using the method 2, how to find a given number of rational numbers between two rational numbers. So there is 3 steps involved. The first step is to convert the given rational numbers to an equivalent form where both the rational numbers will have same denominator, and that same denominator will be obtained by taking the LCM of the denominator of the given two rational numbers. And once we have that, now we will then get R dash and S dash. Now to obtain R double dash and S double dash, what we do is we multiply both the numerator and the denominator of R dash and S dash with n plus 1, where n is the given number of rational numbers we have to find. So in this example, n was 10, so we multiplied by 11 with both numerator and the denominator of R dash and S dash, and we got R double dash and S double dash. And the final step was to start with R double dash, and we keep on adding 1, 2, we add 1 to the numerator, and then we add 2 to the numerator, and like this we add uh, plus 9 in this example, because plus 10, because we have to find 10 rational numbers, and we get the final 10 rational numbers. Now let's do, let's say I will solve just another, let's say find 5 rational numbers between minus 3 by 11 and 8 by 11. So this just, I'm solving another problem to give you a better idea. Now over here, we have r as minus 3 by 11, s as is by 11. So both have denominators same. So we need not, so we already know that r dash will also be minus 3 by 11. S dash will also be 8 by 11, because we did not do the first step, because the first step was to transform R and S to equivalent rational numbers where both will have the same denominator. The same denominator will be the LCM of the denominator of R and S. Now, since the given two rational numbers in this problem is same, they have the same denominator 11, so we already have R dash and H dash as minus 3 by 11 and 8 by 11. Now, to find R double dash, we simply multiply, since we have to find 5 rational numbers, we will multiply the numerator and the denominator of both R dash and H dash with 5 plus 1, that is 6. So 6. So this becomes minus 18 by 66, and this becomes 48 by 66. Uh, okay. So now we start with R double dash, and we keep on adding 1 and then 2 and 3 up to 4. So the final rational numbers will be 1 by 66, 2 by 66, 66, 66, up to 6, because we have been asked to find 6 rational numbers. So this becomes minus 17 by 66 minus 16 by 66 minus 15 by 66 minus 14 by 66 minus 13 by 66. We have to find, we have to, we have been asked to find five rational numbers. So this one is not required. So these are the five rational numbers that we have found between minus 3 by 11 and 8 by 11. I hope this will give you a better idea. So that was all for the solution of the assignment 1 and with some bonus problems. If you are if you are having any problem in understanding my lectures or any concept, then please let me know in the comment section. Then I will understand if you are having any issue or not, and I will try my best to address them with my best of my ability in future video. So please let me know if you have any kind of problems with my content, or if also let me know if I am doing any mistake anywhere in the calculation. I will appreciate that. Thanks for watching, and until the next video, take care and bye.